Okay, so here we are on the second portion of this video where I'm going to be showing you how to test some of these components. And there's a lot of components out there, but the good thing is if you can test one, usually you can test all of them. There are some that you're not really going to be able to use a multimeter for. And in this case, we're going to be doing two things. We're going to be using a cheap multimeter. This one is just it's like maybe $20, $25 or something like that, okay? And I'm also going to end up using a capacitance tester right here. And this same thing, about 20 bucks off of eBay. They have some multimeters that test capacitance as well. I have a Fluke that ordinarily I would use, but this is probably what you're going to be getting for your first multimeter, and it works. I've got a couple of these, and I use them all the time in my guitar shop because I don't care if they break, and they work, you know, and it does everything that I need. The capacitance thing I rarely use. Here in the guitar shop, there's really no need for it. There are some capacitors in the guitar, but I usually don't use it. This is basically when I'm doing arcade repair, or I'm having to repair a board out of something. Okay, so these are really the only two things that we're going to need. And I guess I should go ahead and go over how a multimeter works, just in case you've never done it before. All the things that I had mentioned before with the components and how they work and everything, well, this pretty much, depending on where you turn it, you're setting it to measure a component. So every multimeter, for the most part, is going to have something that tests resistance. It's going to test it's going to test amperage. It's going to test voltage, and it usually will have a continuity tester. Okay, a diode checker. Okay, sometimes you'll see them where these things have got things that test capacitance. I've never used the capacitance tester on this. I don't even know if it's any good. Sometimes it'll even check temperature, like this one. This particular one also has a thing to test transistors. I never use it. Okay, but most multimeters will have stuff like that. And right here, resistance. Right here, DC voltage from here to here. AC voltage from here to here. It's the AC amperage or current, and from here to here we have the amperage from DC amperage. Okay, and that's really all you need. Okay, for your first multimeter, that's really the only thing that you need. This one is not a meter that is self-adjusting. It's not self-calibrating, and so you kind of have to know what you're measuring, the value it's supposed to be, so that way you can get the proper reading. Generally, it's better to start high if you don't know and work your way down. Okay, generally. So let's go ahead and get started and test a couple of things. Let's start with. Let me get a couple of things over here. I should have brought some resistors in here. But let's start with an electrolytic capacitor. This one's closest to me. Doesn't matter what color they are. They come in all sorts of different colors. They come in different shapes, but they're almost always circular like this. Okay, almost always. And if you look at it, you're going to see that it says 330 microfarad. It's going to say at 50 volts. 50 volts is the maximum amount of voltage it can handle. Okay, the microfarad is basically talking about the charge, the capacitance. Okay, if you ever have to replace one of these, you can always increase the voltage, but the farads have to be the same. Okay, and all of these components have what's known as a tolerance, and the tolerance basically says, well, if this is 330 microfarads, there might be 5% tolerance, 10% tolerance, or something like that, which basically means if it's 10%, you can go 33 microfarads either up or down, and it's considered good. And resistors are like that. You know, pretty much every component has a certain level of tolerance to it. The higher the quality is, the lower the tolerance. You know, but there's some up there that's like 25% tolerance. You know, whatever. But these are cheap. Electrolytic capacitors are cheap, and so you know it's cents. It costs cents to buy some of these, depending on where you get them. You're also going to notice that you have a long lead and a short lead when they're brand new. Short lead It's going over here to the negative. And you're going to hear you're going to hear things like cathode and anode and stuff like that when you're dealing with electronics, and that's just referring to either it's a positive or negative lead. Okay, but anyway, the negative side is clearly marked. Sometimes it has a marking here, but it'll say it's the positive side. So you got to pay attention. But you'll see that the positive is longer, this is shorter, this is the negative side. These need to go in exactly the way they're supposed to go in. So if this is where the negative was, that's where you've got to put it. Like so in the circuit board, if it was here before, that's where you got to put it. If you flip it around, you're going to end up creating problems. This thing can heat up and this top will go pop, and it'll pop off. As time goes by, these electrolytic capacitors go bad as time goes by. And sometimes they last for a long time, but other ones, they leak. Okay, and sometimes if you look at the base of them, especially on an older one, you might actually see leakage. You might see stuff coming out of it. You might see this bulge, okay, where the top of it might be bulging or something, or this looks like it's kind of opened up and exploded. And all of those things are dead signs that the capacitor is bad. So when you see, you always do a visual inspection first. You know, everything should look brand new. Okay, if you see anything that looks burnt, anything that looks bulging, anything that's discolored, anything that looks like it's leaking, anything like that, that is something that you need to look into. Those are culprits, possible culprits. But let's say we have taken this out of the board, and now we're going to test it. Well, lucky for us, it tells us 330 microfarad. That's what it's supposed to be at. So if we come over here, and this has got two different ways of testing. I can take this, and I can put this inside here, in these like little holes up here to test it. But this is supposed to be 330 microfarads. So I'm going to come over here to 2000, and testing it, this says that this is 309. Okay, now depending on what the tolerance of this is, okay, that would be okay. Let's test another one of these guys. You'll see different color, but you're going to see something pretty much the same. The short one is the negative. And come over here, push this guy inside. This says this is 107, and this is saying that this is 100 microfarads at 63 volts. So this is good. This is fine. And pretty much that's how you go about testing it. Now if I were to put this down here on like 2 microfarad, and I'll just use the same one, and I were to try to measure this, you might think that it's wrong, like it's got a bad, you know, like something's bad in there. Okay, but as I start increasing it, that's when we start getting different numbers. Now, if I put this all the way up here to the top, you say, oh, well, this is only 0.10. That's supposed to be 100 and, you know, whatever. That's why it's important to know exactly what you're supposed to be measuring. You know, what you're supposed to be getting. Okay, you kind of need to know that. So when you have these things that are not self-calibrating and you have to adjust it yourself, you know you're going to get the right reading. Okay, and usually the biggest, usually capacitors, easy. At least electrolytics, we have a different kind of capacitor, and it's basically like this. This is non-polarized. In other words, you don't have to worry about the negative side or the positive side. And this comes in a lot of different shapes, sometimes in a lot of different colors. You might see one that's yellow, that's skinny and tall. You might see a green one that looks like a little chiclet. You're going to see all sorts of different colored ones. You'll see some like this that are ceramic, and it's round, and it's orange, and it's like a ceramic, like clay. It's going to be almost like it's clay. Those are all non-polarized capacitors. A good thing about these, you don't have to worry about if it's negative or positive, which side is which, because they're basically the same. But let's say we don't know for sure. This one says 0.47K, but usually these have a low capacitance. You know, we're not going to be up here in the microfarad. Usually it's not. But we can come over here, and by me putting these leads on here, oh, wait a minute. Am I using, oh, I'm using the one from the multimeter. Make sure that you use the proper ones, or you won't get any reading at all. Okay, so I've got this on here. I'm not getting any reading at all. But as I start going down, there we go. There's our 46. There's our 46. And now you'll see that once again we're not getting anything. And this is really the kind of like the problem with having to do this yourself, like moving it back and forth, is because if you don't know what it is, you know, it might look like it's a bad capacitor, it might look like it's a bad resistor, you know, but so you kind of want to just kind of move it around and see if you get a reading. Now this is saying it's 0.470, and if we look at this, it's even written on there, 0.47. This is good. Okay, now that only checks the capacitance of this. There's also another thing called ESR, okay, and you need an ESR meter, and that is the thing that really tests the capacitor to make sure it's 100% good. Okay, generally testing the capacitance is enough. Generally it is. Okay, but even though that this might pass the capacitance test, it might not really pass an ESR test, right? And so the capacitor could test and look okay, but it actually might not be. Okay, and sometimes that does happen. Okay, when in doubt, just replace the part. When in doubt. But I would say a good 80%, 90% of the time when you test it, just testing the capacitance. If it says that it's okay, it usually is. Okay, but every now and then you'll get a reading that's like it's acceptable, but when you do an ESR, it's like, whoa, hey, okay, well this is creating a problem, because all you need is one component, just one little thing like this to go wrong on a circuit board, and the thing won't work. All you need is just one thing to go wrong. All you need is one thing like this to go bad, and it can damage other parts that are in the circuit. Okay, it can fry stuff. All you need is just one little thing to go bad, and so it's important that you don't overlook anything, and you know, don't take anything for granted. Good thing is, capacitors like this don't usually go bad. Okay, usually they don't. This, yeah, these go bad a lot more often. On most of the stuff I repair, I'm replacing these in transistors and diodes more than anything. Okay, so those are the capacitors, and that's pretty much how you go about testing them. And like I said, this is going to be a major culprit. When things go wrong, look for the electrolytics. That's the very first thing that I mean, when I'm scanning a board, that's one of the very first things that I'm looking at is the electrolytics. Seeing if any of them are bulged, see if any of them are popped, if any of them are leaking, you know, all that other stuff. That's one of the very first things I look for, okay, because it's something that you can visually tell if it's wrong. So let's go ahead and close this up. Real quick, like, let me go over these, okay. This is just some of the ones that I have, but these are ICs that I had mentioned before, okay, integrated circuits, and each one of these is going to have a different number and stuff on it, and there's going to be a different number of pins depending on what it does. You can't really get a multimeter and test these guys, okay. A lot of these are, well, there's ways that you can do it, but usually, depending on what type of IC it is, you would use something like a logic probe, or you know, a logic analyzer or something. But sometimes these things are amplifiers. They're not logic gates. They're like amplifiers and stuff. Sometimes they're voltage regulators. Okay, and you'll see stuff like this. You'll see things like this. This one looks like this is. If this is an 8631, I think this might be a CPU. This is a Z80. This is an old CPU. This is the type of stuff that used to be in arcade games, and if I'm not mistaken, this was what was in the Atari 2600, if I'm not mistaken. But this is like an old CPU, and this might be a CPU too, but this also might be like for a math box for a couple arcade games that I've repaired. Kind of hard to say because I've got tons of these. But you're going to see all sorts of different types. This right here is memory. This is RAM right here. Okay, like that's RAM, and you'll see that there's going to be some that are different sizes. This is RAM as well. This goes to a millipede RAM. Okay, this right here, another one, and if I'm not mistaken, this one has something to do with sound in a pinball machine, and I think it might have something to do with controlling the what the hell do you call that? A voice synthesizer. Point is there's a lot of different little ones, a lot of little different ICs here. This looks like a 555 timer. Let me see if it is. It's so hard to see. What is this? My vision is so bad right now, it's not even funny. But you'll also find little guys like this. Each one of them has its own purpose, its own, that's RAM. That comes from Battlezone. But all of these have their own purpose, and there are tons. I can't even tell you how many ICs I have in the other room, probably thousands. And I don't even have a full collection of all of them. Okay, but I do a lot of old repairs, and you know, I look at the part number. I'm like, okay, do I have this part number? You know, what is it? What does this thing do? You know, what kind? Is it a logic gate? Is this, you know, what is this thing doing? Is it an amplifier? What is this? And they can go bad. If one of these things go bad, that can make the whole thing not work once again. And also sometimes these things look like they're working. They're kind of intermittent, right? And it can make it work. Sometimes it works, sometimes it doesn't. And you have to know how to test these things. And unfortunately, I can't tell you how to test these with the stuff that I have here, because each one is completely different. And you have to kind of you have to get the sheet for that particular IC, see what it is. And I have an IC tester that I get these and I just plug it in. And it doesn't test all ICs, but it tests a lot. And then it tests them and it goes, yeah, this one's good, or no, this one's bad. Okay? And you're only going to be coming across these if you're going to be doing like old computers and stuff like that most of the time. Okay? If you're going to be doing like old amplifiers and things, old radios, you're not really going to be seeing too many of these. And if you do, there might only be like one or something, maybe two. Video games, on the other hand, tons of these. And it's a must to have an IC tester and a logic analyzer and a logic probe and all that other stuff. I'm not going to be covering these too much, because that in and of itself would be a video that would last hours. Okay, so let's go to the next thing. And since I have some up here, we'll just go ahead and do it. Here's our diode. Okay, so this is what our diode looks like, and they come in different sizes. Some of them are orange. Okay, some of them are not. I mean, usually they're black with silver or white, but sometimes they're orange. Okay, and there's different kinds. There's linear diodes and stuff like that too, and whatnot. But we've got some other. This is the atypical, you know, diode like that. But I think these are diodes right here. You'll see these too. Now this is what's screwed up. Sometimes there's actually capacitors that look like this. Okay. There's capacitors that look like that. That's kind of lame, but that's the reality of it. Okay. Sometimes there's capacitors that look like that. So don't automatically assume when you're looking at the board that, hey, this is a diode. Sometimes it's a capacitor. Okay. And really, you need to have a set of schematics, and the schematics is just a drawing of where everything is, and it's usually labeled, and it tells you what's what and what the readings are supposed to be. It tells you what the values are supposed to be. Schematics help you, and you can usually download them off the internet. But a diode, what we remember with a diode, it allows electricity to go one direction, but not the other. So what we're going to do is we're going to take this and move this out of the way. You can do this with an ohm meter too. Okay, you don't necessarily have to use the diode tester. But right here we see that the silver line is on this side. I'm going to put the negative on this side. I'm going to put the positive on this side, and we're getting a forward of about 0.71. Okay, you're going to see it between like usually around like 5.5 something, 0.7, yeah, something like that. That's generally okay. Okay, now if I get these and I flip them, and I put this here and this here, we don't get anything. Okay, that tells me that this diode's okay. And if we were to get something though, by me putting it like this, that diode would be bad, because it's only supposed to allow current to go in one direction. So that is the easiest way to test a diode. So diodes are real easy to test. Okay, and that's pretty much how you do it. a lot of these components, in fact almost all of them, you really need to take them out of the circuit to test. And I'm going to show you basically how to do that here in just a little bit. We have our transistor. And the transistor, once again, if you look, well, you're not going to be able to see it, but if you looked real close, it'd be writing on the front of that. Okay, that, once again, that's the part number and all that other good stuff. But if we set this down, I still have this on the diode tester. This is either going to be an NPN or a PNP. Okay, and we know that this is always the emitter. Okay, so the base and the collector over here. And what we have to do is, it's the base that we need to find out what it is. So I'm gonna say with the middle one here is the base, and I'm gonna put the negative on it. Now, by doing so, I'm assuming that this is a PNP, which it probably isn't. It's probably an NPN, but I want to show you anyway. I'm gonna use the positive and go to the outside. I don't get a reading, and I don't get a reading when I touch these two. Okay. Well, either this is not the base or this is not a PNP. So let me go ahead and come over here, and what we're going to do is we're going to put the positive on the middle, assuming that this is the base. Okay, because if this is not the base, this is the base. But now I'm going to put this out here, and just like a diode, we get a reading. Just like a diode, we get a reading. Okay, now let's say that that was not the base. Okay, same thing, I put my lead here on the outside. I don't get a reading. I don't get a reading. Okay, let's flip it around and see what happens. I get a reading. I don't get a reading. Okay, so you see that you need to know which one is the base, and messing around with this a little bit back and forth, you can usually find it. If I don't get a reading on one of those after I know it's the base, then it's bad, you know. Or during the time that I was doing this, where I had, okay, like when I was doing it like this is how it's supposed to look. I get a reading, I get a reading, okay. But that's with it being N, negative, P in the middle on the base, N, okay. Now, but if I were to do this as a PNP, and I were to put this here, it's not easy trying to do this, and I were to try to test it, if I got a reading like this, that means it's bad. You can't have an NPN and a PNP at the same time, right? So what you end up doing is you test it like that to make sure, because you might get those readings and say, okay, it's good, but you have to do the opposite readings too to make sure you're not getting any leakage. And you test them, and you might see that this one doesn't give you nothing, and then you test it over here and it's giving you a little bit of leakage. This transistor's bad, you got to get rid of it. Okay, but that's how you test them. Okay, this is another transistor right here. Okay, these sometimes are used for voltage regulators and all sorts of stuff. These can be tested like a regular transistor, but sometimes they can't be. Okay, it just depends on what's going on inside this guy. But this middle part right here is usually the center. Okay, so you can test up here. You can hold this thing here, come over here and test this and say, okay, we're getting a reading. We're getting a reading. Okay, now let's go ahead and reverse this, putting it here, which is usually negative anyway. And we're getting a reading, but it's really high. Okay. And we're getting a reading, but it's really high. Now, I know that this is good, okay? But you're going to look at that and say, well, this is bad. You know, I shouldn't be getting a reading, okay? That's because you really need to know how each one of these packages, and the shape of it is what they call a package. You have to look up online, look at the number that's on there, find out what it is, and basically what kind of numbers you should be getting. Okay, sometimes you can test it like a regular transistor and it's just like that. It works just fine. But other times there's things that are going on inside here that end up making it where you can't really test it like a normal transistor. Okay, and so if you do test and you see something like that, don't freak out. Don't be like, oh my God, this thing's bad. It might not be, but you're going to have to do a little bit of research online to find out exactly what these are supposed to be giving you, the readings. Okay, I have a transistor tester inside inside the room, and I take that and I stick this inside there, and it tells me exactly what it is, and it tests it, and it tells me if it's any good. Okay, so I don't have to look up online. Okay, that just makes things a lot easier. But this is something that when you're doing electronic repair, this is going to be something you're going to be doing a lot of. You're going to be with a magnifying glass looking up these numbers, and you're going to be doing research online for these parts. And then you're going to find out that a lot of these things aren't even made anymore. Then you're going to end up having to find a comparable part, you know. And it can be a pain in the butt sometimes, quite honestly. And sometimes you're not even going to know. You're not going to be able to find any of the information that you're looking for, you know. But there's a lot of research that goes online. The good thing is, most of the stuff that can go wrong, and like I said, when in doubt, just replace the part. Something like this usually isn't very expensive, 70 cents, 80 cents, okay? Usually. When in doubt, just replace the part, okay? Now I have so much testing equipment that, you know, I'll always know if something's bad, okay? I've got so many reference books and so much test equipment, I'll know. And, you know, I have an oscilloscope, I have all sorts of stuff. But you are probably not going to have that stuff. You're only going to have maybe this. You might not even have this. But even with this, you can do quite a bit. But you're going to have to do some shotgun repairs. And shotgun repairs basically means, you know, you're going to end up just like replacing a bunch of stuff, even if it isn't bad, just because you want to have all your bases covered. And that happens a lot when people are first starting. But once again, transistors, you can get a transistor tester. Okay, but the small transistor that I had shown you earlier, that's how you go about testing them. You're also going to see power transistors like this. It's the same thing. You test it the exact same way. So let me move all this stuff out of the way here. Okay, so we will put, we'll just see if this is an NPN or a PNP, but we'll put one side here, okay, and we'll touch one side. We don't get a reading. We don't get a reading. Okay, so let's flip it. We get a reading. We get a reading. That's good. So checking resistors, it's pretty straightforward. Resistors have a color code on them. Let me just pull one of these out. I don't even know what this is, but they have a color code on them, and they come in different colors. Sometimes they're white and square and big and stuff. Just depends on the wattage. And each one of these colors represents something. And you can find the chart online, okay, of what it represents. And it basically just tells you what the value of this is, okay? It's just a value, that's all, okay? But let's say you don't know the value. What we do is we come over here and we set it to, let's pick 200K as a good start. I come over here, boom, boom. I'm not getting anything. Okay, so let me see if I can hold this with just one. I'm lowering it, I'm not getting anything. I'm not getting anything. I'm not getting anything. Go up to 2 meg. Ah, there we go. Now we got something. 0.35 mega ohms. But see how, look at how that's changing. Okay, part of that's also because I'm holding it. I'm helping to conduct this. Okay, now we have a constant. All right, so we have 0.45 mega ohms. It's basically like 500K ohm. That's probably what this is, 500K ohm. And there's a tolerance, okay? This could be 44K, but there's a tolerance, and then that tolerance maybe is 10%, maybe it's 20%. So if this is 500K, it gives us 50, you know, 50K either way. So 550K or 450, okay? And it would be considered fine, okay? That's if you ended up having the 10%. If it's 20%, I can go 100K either way, you know, for the most part. And that's no good, you know, as far as I'm concerned. But that's how you test a resistor. And the better quality the resistors are and stuff, obviously the higher tolerance there's going to be. But the color code will tell you what the tolerance is, okay? There'll be a little line and it'll tell you what the tolerance is. The resistors rarely go bad, okay? They rarely go bad. And when they do, it usually just burns up. And you'll look at it and you'll see it burn up, or you'll see it just like broken and separated or something. You'll see heat, like a problem with heat. And that's the reality of resistors. You know, they rarely go bad. Okay, so let's get to the next thing. And we're kind of in luck because I'm going to show you here. I have a turntable that basically just stopped working for whatever reason. I have no idea why it stopped working. It was working, then it quit. It doesn't really amplify, and it doesn't turn. Okay, so I had taken the back off, and you're going to see that there's really not a whole lot of stuff here. Let me move all of this so you can see really well. There ain't a whole lot here, is it? Okay, more plastic than anything. So how do we go about figuring out what's wrong? Okay, well, we're gonna look at this, and we're gonna see what is likely the culprit. It is not amplifying. Okay, so even though the thing doesn't turn, when I rub my finger over the needle, it doesn't really make any noise. Okay, so there's a problem with amplification. I should be able to hear that. Even if this motor went bad, I should still be able to hear that. Okay, now let me look back here to see if there's anything. Okay, I don't see anything. So that's the first thing. We know that there's two things wrong. So what that tells me is if we're getting a non-working motor, and plus there's like no amplification, it tells me that there's probably like AC current that's leaking through the circuit, or there's just no power going to it. So you always start with the power, and the power comes in through here, and it goes into this. So right here we see 4 diodes, and these 4 diodes are acting as a rectifier. And a rectifier, what that does is it takes the AC current and it turns it into a DC current. If one of these goes bad, that could be creating the problem. We have an electrolytic capacitor here. This is acting as a filter. Okay, so we're gonna remove these things. If I get this, I'm trying to move this in a way that you'll be able to see what is underneath here. I'm trying to get it where you can see what's underneath. But right here we have a transformer. Okay, so the power is going into this board, and from here it goes into the transformer. Okay, so right from the wall goes into the transformer. The transformer, looks like there's 2 lines coming out of it. Yeah, there's 2 lines coming out of it here and here. So at this, it's probably a step down transformer, so it's lowering the voltage. After it comes into here, if I turn, this is going to drive me crazy. Hang on for a second. Okay, so now I can move this. I'm trying to turn it over so you can see exactly what I see. Okay, let me zoom in here. Okay, so it comes in through here because it comes out of the transformer. And from here you can see this is a trace. Do you see how it looks like it's like a light green and it's cruising like this? These are traces. Okay, sometimes these traces get scratched up or they break or whatever. Okay, and if that's the case, you have an open circuit, so you have to fix it. Okay, solder it back together, or use a jumper wire. Another thing that can happen is if you look at these, this is where it's been soldered. Another thing that can happen is what's known as a cold solder joint. And a cold solder joint is where the solder just kind of breaks, and it creates this little ring that's very hard to see. It's very hard to see without a magnifying glass and good light. But that little break makes an open circuit. It's not making the contact that it needs to. Happens on old video games all the time, especially in the monitors. Okay, and it's the easiest thing to fix, because all you have to do is to take a soldering iron, put a little solder there, boom, 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 it's fixed, it's done. Okay, but we have the power coming in here. It goes into this diode, which is right here. Okay, it also goes into this diode, which is right there. Okay. This one, power's coming in, boom, boom. Now keep in mind, this is AC current right here that's coming in. It's not DC current. These diodes, that's the point of it. They're taking that AC current and it's turning it into DC current. Because remember how electricity or current can only go one direction in a diode? Well, that's what it's doing, is it's saying, okay, well, during the time that it's positive, I'll let you through, but during the time that it's negative, I won't. And the other side is saying, during the time that you're negative, I'll let you through, but during the time that you're positive, I won't. Okay, and then that's how it rectifies it. That's what's known as a rectifier. Okay, so it's coming through here. If one of these diodes is bad, that could be creating the problem. Okay, so what we're going to do is we are going to test these diodes. And you're going to say, well, how in the hell are we going to test these diodes? They're on the board. You're right. We have to remove them. So I'm using my desoldering gun to remove the solder from one side of the diodes, like that. Okay? And then from here, on this side, I'm going to try to pry them up. So I'm just going to use these wire cutters to pull it up. I'm not cutting them, I'm just grabbing them and pulling them up. And I'm trying to, there's actually a tool that you can use for this that I have in the other room. I just didn't grab it. But now that these are out, okay, they're no longer touching any of the metal in the back. They're isolated, okay? And if they're isolated, now I can test them and they're no longer in the board. Okay, so we can go ahead and put this on diode checker, getting that reflection. Let me see if there we go. Okay, so we'll come over here and we'll test it. Okay, we're getting a reading this direction. Are we getting a reading this direction? No. So we'll test this one. No reading that way, but a reading that way. So far those first two are checking out okay. I'm not getting a reading that way. I'm not getting a reading that way. If I come over here, okay, that's good. That's good. Those test out. Okay, so that means that can't be the problem. Okay, and I would push these guys back in and then solder them back in place. Okay, that's an easy way to take it out of the circuit so you can test it. Okay, so that's good. Now, what about this capacitor? Is this capacitor, you know, the culprit? Is this guy the thing, this filter? Is it leaking? Is it being a bad boy? What, you know, what's we don't know. Okay, we can test that. More than likely, it is not this capacitor. Okay, more than likely. And, you know, what we can do is come over here, once again, desoldering gun. Remove that. Remove that. That looks like I can probably get it out of there now. Now, what I'm going to do is I'm going to go ahead and use my capacitance tester to see if this is any good. This isn't okay. There's glue on this, so I can't see exactly what the value is supposed to be, but it says 16 volts. Okay, so sometimes it'll be written on the circuit board what it is. Okay, but I don't know what this is. So I know that it's probably going to be a little higher than one might expect. So so I have this on the 20, I'm not getting anything. The 2, I'm not getting anything. Okay, I'm not getting anything on this, but that doesn't mean that this is bad. It's just because I stuck it inside there. Okay, so that's one of the problems with having something that you have to adjust, because you don't know exactly what the reading is supposed to be, what the value is. Okay, so right here, this is saying that this is 1,000 microfarad. So I tried scraping it off to see what it's supposed to be, and I can't really see it. But just to be safe, I'm going to go ahead and just replace it. Okay, so I've got another one. The voltage is higher on this one, but it's 1,000. This side is negative. If we look at the board, it'll even have like a little negative right here that tells us. If that negative is missing, okay, what we can do is we can actually, where it comes in, we can push this, but this is negative. It even says on the board right here. And then we can just find ground somewhere on the board and put the continuity tester, and if it beeps, then it's like, oh, that's got to be negative. Okay, so, but this, it tells us right here which one is negative. So what we're going to do is we're going to go ahead and replace this. It doesn't really need to be replaced, honestly, but let's just say that this thing was bad. Okay, so I get that, bend that over. Once again, I'll end up using my desoldering gun just to solder it back up, which is generally not how you do it, but always remove these guys right here. You don't want any of that stuff sticking out. Okay, so right now, as of this point, okay, all of these components look good, except for we don't know about the transformer, do we? Right? We didn't test the transformer. Now the transformer is a coil, okay? And because it's a coil, we can take a measurement, like a resistance measurement, and see if, you know, if we get something. If it's an open circuit, well, that tells us that the transformer is bad. Okay. Problem is we might get something that says that it's not an open circuit and it's closed, but it could be a reduction. It could one of the coils could have melted together, and it could have like just be a reduction in voltage. So it would look like the coil's okay, but it really isn't. Transformers rarely go bad. But what we can do is we can take this, you make sure you put this type of stuff back on because it prevents things from grounding out. But I want this back on here before I do what I'm about to do. Okay, so now that I have that back together again, we know that the capacitor is good. We know that the diodes are good. Okay, so the rectifier should be okay, but we need to test. We need to test to make sure that that transformer is good. So only way for me to really do this effectively is to plug the damn thing in. So anytime you do this, it's always a risk. Hey, you hear that? It's working. It's working. That's crazy, because the only thing I did was resolder the only thing that I did was just put a new capacitor inside there and you know, check the diodes and resoldered them. It's possible. It's possible that there was a cold solder joint or something on those diodes, and I just didn't see it. It's also possible that that capacitor, actually the capacitor was bad, right? So that's really bizarre, to tell you the truth. That's really strange. I didn't think that this was going to end up being repaired so quickly. Actually, I apologize for that, because I was hoping that I could keep going. I was hoping that I'd be able to kind of keep going and showing you about, you know, how I go about, you know, repairing this stuff and then just kind of tracing the problem. But that fixed it. Strangely enough, that fixed it. And I got to tell you, I'm confused on why that fixed it, because the only thing I had replaced is this capacitor. And this capacitor, for the most part, is probably okay unless there's something going on inside it outside of the capacitance that was leaky. You know, that's really bizarre. It happens sometimes. There's also another possibility, and that is because I have been moving these wires around and I've been twisting stuff, one of these has a cold solder joint somewhere, right? And since I moved it, it ended up causing it to turn back on again and to work. That's possible too. So I'm going to have to keep an eye on this thing to see if it acts up again, because if it does, it's probably a loose wire somewhere. And if it is, then I need to go through and I just have to hit all of these with my soldering iron. I mean, I'm happy that's all I had to do to fix it, but at the same time I was hoping I'd be able to kind of keep cruising and take you over to like this thing and whatnot and test the motor and all that stuff. Okay, it's back on, it's plugged in. Let's come over here. We're going to be checking for AC current. Okay, so not current, AC voltage. So I'm going to come over here and I'm going to set it to 200 because I know what's coming out of the wall. It's like 110. Okay, I don't want to touch anything on this, even though this is plastic. These are the only two guys that are going to be touching anything. This is the coming in from the wall. Okay. $120 volts. Okay, the amperage is really high. Now what we need to do is we need to see what we're getting over here after it goes through the transformer. Okay, now this is going to be a little bit more tricky. One side, remember we saw one side come over here and touch this diode? So we can touch that. This is saying it's about 10 volts. So it's basically 10 volts. It steps it down to 10 volts. Okay? So we know that this transformer is good. Okay? Power's coming in. Transformer's good. What about rectifying? You know, is the rectifier good? Well, what we're going to do, well, we know that the diodes are good, so the rectifier is good. Okay? Set it to 20 volts because we know that this is going to be running on about 10 volts. Okay? Right here is where the rectified signal comes out. This is the DC, the rectified DC. Okay, I might be able to touch this and get a. We got 12 volts DC. That's what we should be looking for. A lot of times on computers or things like that, you're going to be dealing with things like 12 volts, 5 volts, you know, 9 volts, 7 volts. But usually you're going to see common factors, common things of 5 volts, 12 volts. They get stepped down, okay, a lot. So 5 volts, 12 volts, those are common ones that you're going to see. But even without the schematic, I know that that's right, okay, just because it's so normal, okay. But we know that the power supply is good, okay. Power supply from here starts going to things like different switches. The switches could be bad. If the switch is bad, it's usually the contact points within the switch, right? Like if we cruise up here, let me see if I can zoom in a little bit on this so you can see what I'm talking about. Okay. There's contact points inside there, okay? Sometimes those get oxidized and carbon build up and stuff like that, and it makes it where it doesn't work. So you can clean those. Then all of a sudden the thing works again, okay? So that could be a problem. Okay, we have switches all over the place on this damn thing, but from there the power goes into this. This is going to be where the amplifier goes. This is going to be the thing that controls the amplification for the needle. Okay, this is going to be the thing that's going to be controlling the speed of the motor, basically telling it when to turn on, when to turn off, all that other stuff. So are these switches. That's also going to be happening. This is also going to be determining what part of the sound is going to go to the right speaker, what's going to go to the left. Okay, so let's go ahead and unplug this. So now if we take this and we lift it up, what do we see underneath here? Okay, and let me try to get this in a way that you can really see what the hell's going on. What do we see here? Okay, so we have non-polarized capacitors right here. These are ceramic capacitors. Just some wires. We have our electrolytic capacitors, okay, right here. We have some more ceramic capacitors. These are capacitors, okay. These are film capacitors right here. These green guys. We have a few resistors. We've got a resistor here, here, here. We have one up here. Got a few over here. Blah blah blah. And then we have this bank right here of resistors too. Because well, wait, is it resistors? No, we have a little resistor there. This is an IC 101. Okay, so this is an IC. Sometimes you'll see these guys and it's a bank of resistors and things like that, right? It's just easier than having a whole bunch of resistors stacked up. But this is an IC, okay? So this is an integrated circuit. I don't know what the point of this integrated circuit is, but because I don't see any like IC circuits or transistors or anything like that for amplification and stereo separation, I'm assuming that this is what's in charge of it. I'm assuming that this is the thing that's causing all of that. So this would be a culprit. This would be something I would have to look for to see what's going on. And it says that this is IC 101. That doesn't tell me anything, okay? But if I look up this particular model of turntable, and then I end up looking up that particular part, you know, there should be some schematics or something that pop up, or maybe Sony parts or whatever, and then I'll say I'm looking for this particular thing, and they're going to say this is what it is, and you can order it directly from Sony, or you can buy an aftermarket one, new old stock or whatever. See, so just because it says IC 101, that doesn't help us any. If you take this out, if you remove it, and you look down the side of it, there might be some writing, and I do see some writing on here. It's really hard for me to see, especially with my vision currently in the condition that it's in, but there's writing right here. And so by taking this out and looking at that really close with a magnifying glass, it could tell us exactly what the part is, and we don't even have to really look up online through Sony or whatever for a replacement part. We could just type that particular number in, and that particular number would end up, you know, you get it on eBay or something like that, a replacement part. Okay. Now, for whatever reason, this thing is working again, and like I had mentioned before, it could be a number of things. You know, I'm just going to leave it as is. Could be a loose wire or something. It could have been this capacitor that was bad. It could have been. I think that's strange, but it's possible. Because if the signal, if the power that's coming in is not clean, it can wreak all sorts of havoc on the way that this thing operates. Okay, it needs to be a clean signal. If one of the diodes is bad and you're getting leaky AC, that can wreak havoc on it. Okay, power supply is usually the first thing that you check. You know, unless it's obvious that it's not the power supply. Okay, and you'll notice there wasn't a whole hell of a lot of stuff here for us to check. You know, there was the capacitor, diodes, there was an IC bank here. You're not going to be able to do anything with that. You're not going to be able to test that. You know, it'd be better just to buy the part if you thought it was bad. One way that you know it's bad is, depending on what it controls, you might not have any sound at all. Everything else works, but you just don't have any sound. You've tested all of the other things. You've tested all the capacitors. You know that the resistors are good. You know that diodes are good. It basically leaves, it could only be this. You know, don't underestimate wires being broken, right, or cold solder joints. Don't underestimate that. That stuff happens a lot, but it usually happens in old things. Cold solder joints don't usually happen in new products. It usually is after it's been setting for a while. Like a lot of the video games that I repair from the 80s, it has cold solder joints. Okay, usually it's older things like that, old TVs, old radios, things like that. But this, I'm going to call good for now, at least, because quite honestly, the thing's working. So there's no reason for me to continue trying to fix something that is not showing any signs of problems. You know what I mean? So let me go ahead, put this all together. Oh, this is something else. Always make sure that you have the proper amount of screws and you haven't forgotten any inside there that could float around and accidentally end up touching part of the circuit board and then short circuit something. That would be bad. You could ruin a lot of stuff that way. And when repairing things, it is important to know kind of how the thing operates. You know, you need to know how something works, because if you don't, how are you going to know where to look? You know, for the problem, how are you going to know where to look? But I usually will take it, give it a shake to make sure that there's no screws or anything missing. From here, that's that. And hopefully you learned something from this. And I'm sorry this wasn't damaged as much as I was kind of hoping it was, because I was hoping I'd really be able to get in there and start doing a lot of you know, detective work. And there is a lot of detective work, like, you know, when you are trying to repair something that's like different electronics, there's a lot of detective work. You know, you have to look at everything really close. You have to think about the path of the current, and you know, kind of like you kind of have to just like stop and slow down, think about the direction of the electricity, what it's going through, what it's supposed to look like or do after it goes through the component, things like that. And then you can usually trace, you know, if you do it like that, you can usually trace it to the problem, just depending on what's wrong. Recently I had done that crate amplifier repair. It didn't turn on. You turn the power on, it didn't turn on. I opened it up, I turned it on, and I saw the diode go pop. Okay, excessive amperage. Okay, that tells me there's a short somewhere. And you know, what controls some of that stuff, or what's after that, or whatever. Okay, and I tested a bunch of things. It turned out to be the power transistors. Okay, and after I replaced those, the thing worked. So, but that's, you know, it's like you're going through the natural order of what could possibly go wrong. You know, power supply is a big one. You should always test the power supply. Even if you're getting voltage, if you get AC current leaking, because the AC can leak like over or on top of the DC current. If you get some that's leaking through there, that could wreak havoc. So you have to check your diodes. You have to check your rectifier. Okay, that's a big one. Always check your power supply. And that's pretty much that, guys. If I think of some other stuff to kind of show you, I will. But until next time, I'll talk to you later.